Hey math fans, we're on section 3.1.4. Let's get started. This section is all about solving exponential equations. Please take a moment to pause this screen and take a look at what are called the laws of exponents. So the first law of exponents is called the product rule for exponents. They must have the same base. So in this particular example, the base is 4. And when you have the same base, you can just go ahead and add those exponents. All you have to do is add the 6 and the 3. And what you can do to check this is, if you ever get confused, you can always kind of write them all out. There's actually 4 times itself. It's 4 times itself 6 times. So 1, 2, 3, 4, 5, 6. Now you got 3 more for a grand total of 9. And that's why you add the exponents. The next one is power of a power, and people get this one confused because they think of the other one. These two get often confused. So here we have an example where it's 4 to the 6 raised to the third power. And again, the best way you could possibly keep track of these is to write these out. This is really 4 to the 6th power 3 times. 4 to the 6 times 4 to the 6 times 4 to the 6. And then you can write them out even further. I could write out 4 times itself 6 times, 4 times itself 6 times, 4 times itself 6 times. You're going to get 4 times itself 18 times. Okay, so that's called power of a power. The next one's called power of a product. It acts a little bit like distribution, but I don't want you to use that word distribution. If you have 2 numbers that are inside the parentheses or a product, like 4 times 2, and it's being raised to the third power, you can divide them up, or in other words, say it's going to be 4 to the third power times 2 to the third power. And it almost looks like that 3 is getting distributed, for a lack of a better word, but it's called a power of a product. The next one's called the quotient rule for exponents. Now remember, if we have the same base and we were multiplying them, we were adding the exponents, but now that we're dividing, wouldn't it make sense to subtract the exponents? Again, an easy way for me to remember how this works is I will actually write out like 4. This is 4 to the 6th power, so it's 4 times 4 times 4 times 4 times 4 all over 4 to the third power, which is 4 times 4 times 4. If you ever get confused, you can always do something like this. And you kind of go, well, wait, 4 over 4 is 1, 4 over 4 is 1, 4 over 4 is 1. You're left with 4 to the third power. Anyway, that is called the quotient rule for exponents. And the next one is exponents of 0. We've already been over why anything to the 0 power is 1. And then continuing with the theme of anything to the 0 power is 1, well, what happens if that exponent turns negative? We've already been over that. Remember, it turns into a reciprocal. Again, follow the pattern. I'll write out the pattern here for 4. Following the pattern, we're dividing by 4, dividing by 4, dividing by 4. That's how you get 1. And then if you divide by 4 again, and divide by 4 again, notice how that exponent, that negative exponent, it just becomes a reciprocal. And notice all of these answers are still positive. So example 1 says 4 to the x power equals 1024. For these problems, it's helpful to just make a list of all the different values for that particular base. And notice it's not until we get to 4 to the 5th power, we get 1024. So notice how it's written here. Once you get the same base on both sides of the equation, you can then set the exponents equal to each other and then solve. Final answer is x is equal to 5. Example 2, solve the equation. 1/2 raised to the x power equals 16. I could separate the two and make it 2 to the negative 1, and then raise it to the x power is equal to 2 to the 4th power. So now I have down here 2 to the opposite of x equals 2 to the 4th power. Now I can just, because these two have the same base, I can set them equal to each other, correct? So we got the opposite of x is equal to 4. Therefore, your final answer down here is x is equal to negative 4. Of course, you should always go back, check your work. Does this make sense that 1/2 raised to the negative 4th power, is that going to equal 16? And you can check that on your calculator. Of course, go through the process as well. Doing the reciprocal, that's really 2 to the 4th power, and 2 to the 4th power is 16, so it checks out. Example 4, solve the equation. 117 equals 5 to the x minus 8. In a problem like this, before you start messing with the exponents, you really want to isolate the exponents. So let's get rid of that negative 8 by adding 8 to both sides. And then we get 125 is equal to 5 to the x power. 5 to the 3rd power is going to be equal to 125. Our bases are equal. Therefore, you're going to get 3 is equal to x, or x is equal to 3, symmetric property, and you're done. And that's going to do it for this section. We'll see you in class.